All right, let's dive right into this. For decades, artificial intelligence was, well, it was mostly just science fiction, right? We're talking about the cold, calculating logic of HAL 9000, or the incredible conversational nuance of Samantha in that movie Her. But AI isn't just some futuristic concept anymore. It's here. It's literally the invisible engine driving our modern world. So today, in this explainer, we're going to look at exactly how we arrived at this moment. Because the evolution of AI, it isn't just about building faster processors or bigger hard drives. It's actually this fascinating story of how humanity learned to teach machines to think, learn, and adapt.
To make sense of this massive 70-year history, we're going to break it down into 5 clear, digestible chapters. We'll start with the science fiction dream, move into the symbolic AI era, explore the learning revolution, discuss our current generative AI boom, and finally, look at the ethical crossroads we find ourselves at today.
Chapter 1. The Science Fiction Dream, the Initial Ambition.
So the whole story really kicks off back in the mid-20th century. Picture this. It's 1956 at the Dartmouth workshop, and a group of visionary scientists confidently coined this brand new term, artificial intelligence. They genuinely believed that human intelligence could be so precisely described that a machine could easily simulate it. But, progress wasn't a straight line up, not at all. There were massive peaks of innovation followed by these really deep valleys, like the infamous AI winter of the 1980s. But then, things rocketed back up with massive breakthroughs, like AlexNet in 2012, which led us straight into the generative AI era of the 2020s.
Chapter 2. The Symbolic AI Era. The Rule Makers.
The scientists of the 1950s and 60s operated on a concept we now call symbolic AI, or sometimes researchers playfully call it good old-fashioned AI. And honestly, the approach made total sense at the time. The idea was, if we can just give a computer enough strict rules and logic, it can solve absolutely any problem. Think of it like a massive, incredibly sophisticated flowchart. The programming was entirely conditional. If X happens, then do Y. If A is true, conclude B. And to be fair, this led to some really cool early breakthroughs. It gave us the very first chess-playing programs. But it eventually hit a massive brick wall. Why? Because the real world isn't a chessboard. The real world is messy, it's contradictory, and it's filled with nuances that simply cannot be captured by rigid logic.
And this brilliantly illustrates that exact contrast. On one side, we have the rigid logic of symbolic AI. It struggled so badly with real-world nuance that it actually caused that AI winter, that massive funding drought in the 1970s and 80s we just talked about. The technology just couldn't keep up with the lofty promises of its creators. But on the other side, the solution that completely saved the field? Machine learning. This was an absolute game changer, a total paradigm shift. Instead of rigid rules, the system became data-driven. It became probabilistic, and it was entirely focused on finding patterns.
Which brings us to Chapter 3. The Learning Revolution, Teaching Computers.
I absolutely love this quote from the source material. If machine learning was the spark, deep learning was the forest fire. Researchers basically threw their hands up and stopped trying to manually program all the answers into a computer. Instead, they decided to teach the computer how to learn the answers for itself. By feeding vast data sets into algorithms, systems could identify patterns in historical data to make highly accurate predictions. So for example, a spam filter stopped being a strict list of forbidden words and became this dynamic model that actually learned what looks like spam based on millions of real emails. And this whole thing was powered by the explosion of the internet, which provided the data fuel and massive advancements in processing power thanks to GPUs.
Okay, so how does this actually work under the hood? It all relies on something called artificial neural networks. Drawing direct inspiration from the biological structure of the human brain, researchers developed layers of interconnected nodes, or neurons, that process information in a hierarchy. This changed everything. Before this, computers could really only understand highly structured data, like a well-organized spreadsheet. But neural networks allowed AI to finally tackle messy, unstructured data. We're talking about images, audio, and video.
And we can anchor this entire revolution to one specific year, 2012. In 2012, an AI model called AlexNet completely decimated the competition in a major image recognition contest. It wasn't even close. It was a true watershed moment. Suddenly, computers didn't just calculate, they could actually see objects in photographs and hear the subtle nuances in human speech. That single breakthrough in 2012 gave rise to technologies we now take completely for granted. Facial recognition on your phone, voice assistants like Siri and Alexa, and the incredibly sophisticated recommendation algorithms powering your Netflix and TikTok feeds.
Chapter 4. The Generative AI Boom. Creating New Content.
Now we get to the present day.
At the very heart of this current boom are large language models, or LLMs, like GPT-4, Claude, and Gemini. These systems have absorbed a staggering breadth of human knowledge. They've consumed books, countless articles, millions of lines of code, and endless human dialogue. By digesting all this data, these models have developed this uncanny ability to reason, summarize, translate, and actually generate original content. This has completely crashed the barrier to entry for complex tasks. We've democratized access to intelligent tools in a way we frankly never thought possible, allowing machines to seamlessly write our emails, design our logos, and even debug our software.
Now, what's really fascinating here is the massive leap between these eras. Analytical AI, which is the technology we perfected over the last decade, identifies patterns and sorts information. But generative AI, it synthesizes entirely new content. We have officially moved from asking computers to sort our spreadsheets to utilizing them as proactive, creative partners in our daily workflows.
Chapter 5. The Ethical Crossroads. Profound Responsibility.
But of course, as these systems begin to mimic human output almost perfectly, society is facing three major ethical risks. First up, bias and fairness. Because AI learns from human-created data, it inevitably inherits our historical human biases. Ensuring these models are equitable is going to be one of the most pressing challenges of this entire decade. Second, deepfakes and misinformation. When an AI can generate hyper-realistic video and text in seconds, the line between truth and fiction becomes dangerously blurred. And third, job displacement. As AI successfully automates increasingly complex cognitive tasks, we are being forced to deeply reevaluate the social contract of work and productivity altogether.
Let's see how this builds toward our immediate future. We started at Step 1, Analytical AI, sorting the data. We're currently living in Step 2, Generative AI, creating the content. But the very near future is Step 3, Agentic Workflows. This is where AI doesn't just sit in a chat box politely waiting for a prompt. Instead, it acts autonomously. It coordinates between other software, manages complex workflows, and executes massive projects with minimal human intervention.
And that trajectory points to a very specific, almost mind-bending destination, artificial general intelligence, or AGI. This is defined as a machine that possesses the ability to perform any intellectual task that a human can. What is so wild to realize is that AGI is no longer a fringe academic curiosity. While we aren't quite there just yet, the sheer momentum of this 70-year evolutionary timeline suggests we are moving rapidly towards systems that are highly autonomous and capable of incredibly sophisticated long-term planning.
The evolution of AI has been an incredible journey, from rigid, rule-based systems to fluid, generative models that literally mirror the complexity of human thought. We've spent 70 years teaching machines to understand our world, and now they are beginning to help us shape it. But as we stand on the precipice of this new era, it is absolutely vital to remember that it's no longer just about the technical capacity of the hardware. We are the architects of this technology. Its evolution is ultimately a reflection of our own values, our goals, and our ingenuity. The AI of tomorrow will be exactly as smart as we make it, but it's entirely up to us to ensure it remains a force for human progress.
Which leaves us with one final, deeply important question to consider as we wrap up this explainer. As the invisible engine of AI grows more powerful, more capable, and more integrated into every single facet of our human experience, are we truly ready for AGI?